Now, this illustration deals with grounded systems supplied by a separately derived system with overcurrent protection ahead of the conductors on the primary, basically speaking. In accordance with NEC 250.32B as in boy, 2A as in apple. Now, before we get into this transformer located outside supplying the building, let's look at the figure loop. The figure loop says, basically for more information, see figure 16-58, 16-59A and B, 16-60, 16-61, 9-28, and 20-35. Now, the only loop here is that figure 9-28. You'd have to have volume 1 to review it, but you could review all the rest of those references in volume 2, the Stallcup's electrical design book. And remember, volume 1 is the basic requirements of the NEC to particular design and installation. Volume 2 is more complex, it's more advanced. So we recommend using both books, go through the volume 1, then go through our work in volume 2, and compare you can read your code book along with it, those sections, to see if you agree or disagree with what we're saying there. But notice this transformer in the illustration is located outside. It is fed from a upstream device. It could be in a substation or it could be in a building, as illustrated. But notice it's a high voltage. It's 13,800 volts, 3-phase. It's over 1,000 volts. And we say, yeah, it could be fed from a substation or whatever. Customer owned. So rigid metal conduit is in housing those conductors. Burial depths in accordance with 300.50 or the designing engineer's recommendation. There's an overcurrent device outside at the transformer, so that makes that a feeder going inside the building. Now the transformer is grounded outside, and the service equipment is grounded there, and I think 780 would want both of those grounded because we'd want a potential to ground of the transformer, and then we'd want our potential to ground of the panel board in the building. But notice we have a feeder going in, so the equipment grounding bar bonded to the enclosure connected into the electrode system. Table 250.122 would size it. So if you had a 225 amp main or set of fuses on the secondary side of that transformer, then there'd be a number 4 routed into the equipment grounding bar connected into the electrode system or electrode in accordance with 250.50, 250.52, and 250.53. But now the neutral would be calculated by 220.61. And you may have 150 amp neutral, 200 amp neutral, or you may have a full 4-aught neutral in relation to the 4-aught conductor supplying that 225 amp main. So what this is pointing out again, we would use the larger of the neutral calculation, 220.61, or the equipment grounding conductor size per table 250.122 that we've looked at. But now notice this transformer and panel board are earth grounded, in my opinion, in accordance with 250.30A1 exception 2 and 250.32B1 exception 2. We've already talked about the overcurrent device outside at the transformer in accordance with 250.32B2 little a. We have a disconnect there at the transformer in accordance with 450.50, and we've pretty well have covered the rules of the figure 16-57 that comply with NEC 250.32B2A. Notice the mains now. The number of mains to this building are sized by 225.33A, and the number permitted there, 6 or less. And then do not forget 225.32 exception 1, because you may want to use that, and use it in conjunction with 250.71B 1 through 4, and talk to the authority having jurisdiction, so we're all on the same page when you're getting a final on your design and installation, is illustrated in this figure 16-57.